Yeah, Mesh, tell me about yourself.
Yeah, myself, Mahesh. I have done my primary and pre-university education from my native Gulbarga at SPI Public School and College, respectively. I have completed my bachelor's from SJC Mysuru in the stream Electronics and Instrumentation. I'm a 2022 pass out guy, and I have done a 6 months internship at a software company on .NET framework. And as I was always interested in the core electronics and the core VLSI, so that drives me to take, to take a dip into this ocean of VLSI. And so from there, I went into RV VLSI in order to gain some hands-on experience at PD domain. So that is what defines me. And by the way, thanks for giving me an opportunity to introduce myself.
Which batch are you, Mahesh?
I am 2022 pass out.
No, in RV. B?
B48.
48, recent pass out.
Recent pass out.
So you attended that Omni Design?
Yeah, I attended Omni Designs.
How was it?
It was good, like they gave some 36 to 38 questions. But the thing was like they were expecting us to write in, in short keywords. So what I have done mistake was like I wrote it in a more elaborate way.
Understood. Understood. To whom you have talked, I got it.
Why?
Got it. Yeah, talked to one of my batchmate only. You have been. I got it. It's okay. We'll discuss it later. And they took an interview for you or not?
Who?
The Omni Design team.
No.
They didn't shortlist you for interview.
No. They were like, you should be underlining the keywords and all more than this depth question and depth answers.
Fine. Okay. What's your BTech project or BE project?
In BTech, I have done a project on this one, like using ultrasonic sensors. Regarding the wheelchairs.
Okay.
Yeah, there was like we have done a prototype where we built a prototype model of a wheelchair where it was like we have added two things in that. One was like the wheelchair should be operating with respect to the Android mobile app, where there was an app called Android Meets Robot. With the help of that, we have done one thing, and the other thing was voice controlled. Through voice control, also we have made the operation of the wheelchair. Why? Because basically that project we designed for considering the person with disabilities and all. So it was like Android meets robot and all. So it was just a prototype. Even we use some ultrasonic sensors in order for obstacle detection and all. So this is what our BTech project was.
So there are existing wheelchairs in the market which are operated by the joystick, right? I guess it will be on the left side, and you can move forward and backward so that they operate. So what made you to do this project? How will it be unique or different than the existing ones?
Yeah, basically, the joystick one, it is available in the market and it is most widely used. So within that joystick model, so that is what we have added the voice control thing also, because it was like in the by using Arduino, it was like it used to grab the command which is given by the user, and it used to check with the string. If the command is like, if I'm telling it is like right, then it used to check with the string which is written in the code, and if it matches, then it used to operate in that direction. So with that joystick, we have even done this voice controlled wheelchair also. And apart from that, what we have added more in that was like we even tried for example, a person is sitting on that wheelchair. So we even try demonstrating regarding his the temperature sensing and the pulse sensing of the patient, because a person with disabilities, if the caretaker is there, then it is good, but if the caretaker is not there, then he should be getting updates regarding him. So we were like, we even upgraded those things to that same project prototype.
Okay. And then what's the microcontroller you used?
Arduino Uno.
Fine. That's okay. Then we'll go with Krishna. Krishna, introduce yourself.
Good evening, sir. My name is P.
Good evening.
Krishna Reddy. I am from Visakhapatnam. Can I audible, sir?
Yeah, you're audible. You're audible.
My BTech in 2021 pass out, but I am Tech in 2022 release. And in difference between I am working in 7+ experience in naval base.
Okay.
Indian naval
Sorry,
base hardware
you
engineer.
said that you completed your BTech in
2011.
11. I had 21. Okay, fine. Okay, then you worked in
And
the naval
Tech
base.
hardware engineer.
Hardware engineer. What's the role like you do there? Like particular with hardware engineer?
I have a one Indian naval system that's named CI system. That's maintenance and operating.
Okay, fine. What's your MTech? When did you do it?
I'm Tech embedded and VLSI.
Okay.
My pass out is 2022. And I'm trained at DFT engineer in chip edge technology.
Okay.
April 2022, September 2022.
Okay.
5 months.
Okay. What's your BTech project?
Victor is in IFR based parking, car parking.
Okay. How would that work? Like, what are the basic principle of it?
The RFID nothing but one.
No, that's not.
apartment is
I'm
that.
not asking about the RFID. Yeah, the basic principle of your project. Like, how does the project works on simple? If you have to brief it out, how would it work?
I forgot.
Fine, that's okay. What about your MTech project?
MTech project a new energy efficient high throughput input two-phase multi-bit circle ring oscillator base.
What's that?
That is the sorry.
No, what does it do?
It is it means it apply the positive and negative signals at a time. That the rings oscillator working.
So you designed a ring oscillator with the help of this thing.
Help of 45 nanometer and 1.2 voltage CMOS technology.
Fine. Okay. Yeah, Mahesh?
Yes, sir.
Okay. What are the best subjects you are good in electronics?
I mean, I basically like digital electronics.
Fine.
I'm in, now as I'm into PD, I'm much more interested in STS.
Okay, fine. What about you, Krishna?
So digital electronics.
Okay. Then we'll start with the digital. I'll ask question. I'll pick the name. I'll see. What do you mean by a flip flop, Mahesh?
Yeah, basically flip-flop is a sequential circuit. Basically, it acts as an memory element. So, flip-flop is used as a binary, a single bit element. So there are, there are a lot of types in flip-flops, like starting with SR, JK, D, T. So basically, even in the flip-flops, it's like there is an hierarchy why we should have D or why we should have T or why we should have JK, because we already have SR now. So with all the demerits which is followed by the flip-flops, there is some other additional things which are added to the other flip-flops. So this is what flip-flop is all about. Or should I brief it in
No, enough. Krishna, what do you mean by a gate?
Gate. Sir,
Yeah.
here number of gates.
No, I'm just asking you about the gate. Define gate.
I don't know.
Fine. How does a flip-flop store element? Like, how does it store a single bit?
It show stay 1 bit memory, sir. Just 1 bit.
Yeah, how does it do? Like, how does it work?
Um, can I explain, sir?
Yeah, explain. Mahesh, which other companies have been visiting your batch?
No, sir.
Apart from
Till now, we have got the offer only from Omni, sir. No,
okay.
no other companies have visited,
So
sir.
are there saying any other companies coming up, or this
No,
is the
sir.
last?
I mean, no, they are like you will be getting companies, but as you know, sir, now the situation is tough for back-end guys. There are no much openings,
Hmm.
so they are like you have to wait. They are like in March we can have more openings, so
Okay.
we can try.
Yeah, Krishna.
Sir, can you show?
Yeah, I can. Are you attending through mobile or desktop, Krishna?
Mobile, sir.
Okay, fine. Yeah, explain me that thing, whatever you are showing.
Sir, in sir, when you apply the clock input into the AND gate,
Hmm.
and one signal to the AND gate, both are the high, then also pass to the A3 AND gate,
Hmm.
and other is the inverter to
Krishna, I'm asking you to explain how does it store one bit with respect to the waveforms. You explain it using the waveforms. If you know, then explain. Otherwise, we'll move to the next question.
no,
No?
no.
Okay, fine. Mahesh, it's for you.
Okay, sir. I'll draw the waveform.
Hmm. Are you attending through mobile?
No, sir. I'm from desktop only. I'm
Then
attending.
you have this thing. You can use the whiteboard, right?
Okay, in this Google Meet, sir.
Yeah. You have the three dots, right? Press it. You have a whiteboard there. Open a whiteboard. Open a jam.
Okay.
Hmm.
Okay. Can you see this?
You do one thing. Share your screen.
Okay.
On a tab of which you are working, share that. Sorry.
Okay.
Yeah.
Okay. So I am explaining this with respect to D flip-flop. And I'm taking the clock as a positive edge triggered clock. So yeah, basically this is the D input, and with respect to positive edge triggered clock, if I'll take the output of D, so basically in D it's like what will be giving the input, that is what it reflects in the output as well. So considering the positive edge triggered, at first considering this positive edge triggered, it's 0 here. So I'll be taking 0 only till the next positive edge triggered. So at this positive edge triggered, it's 1. So I'll take it to 1 until this. So here also it's 1, so I'll take 1 until this. So here it's 0, so I'll be taking the output as 0. So
okay, but the thing is, when at the starting positive edge of clock, your D will be 0, right?
Yes, sir.
So your output Q will be 0 on the second clock edge, right?
Yes, sir.
Right? It should be 0 on the second clock edge.
No, sir. At this clock edge, I am making the transition, no, sir, with respect to this one. So regarding that, I have drawn, sir.
Okay, fine. Okay, just a minute. You have covered 3 blocks. Okay, fine. That's okay. That's correct.
Okay.
So what's the difference between flip-flop and a latch, Krishna?
Sir, flip-flop is just 1-bit storage element, but latch is the number of latch. Latch is just to tell me.
Fine. Mahesh?
Yes, sir. Sir, can I explain that with the same Jamboard file?
Just brief out. There is no need to explain. Just mention 2 difference between flip-flop and a latch.
Okay, so yeah. Basically, latches are level sensitive, sir, whereas flip-flops are edge sensitive. As I have explained with respect to the waveform only, I took the example of with respect to positive edge triggered. So the data transition happens only with respect to that positive edge triggered. Whereas in latches, it's like it's a level sensitive. If I take it as a positive latch, then the data will be, the data transition can happen at the positive level window, sir. So that is the main difference which we have in between latches and flip-flop.
Can you have the negative level triggered flip-flops?
Yes, sir. We can have negative level triggered flip-flops as well as negative level sensitive latches.
Flip-flops?
Yes, sir. Flip-flops you can have.
Negative level?
No, sir. Negative edge triggered flip-flops.
That's what I asked you. Okay. Negative level latch?
Negative level latch also we can have, sir.
Okay. So if I am asking you to design a memory where you have to use either a latch or a flip-flop, which one would you use?
So, sir, basically, if I explain with respect to this timing analysis, basically, I'll firstly go with the flip-flops only, because in the latches, it's like at some time there can be chopping of the data, sir, in between. See, if it's like when the latch is active for the whole window, and when it is inactive, at that time there is any transition happening, then the latch cannot accommodate that transition. So for that, we'll be using flip-flops. But why even latches can be used instead of flip-flops? It's like in STA, we have to maintain the slack, no, sir. At that time, in some instance, it's like there is one reg-to-reg path. It's like one reg-to-reg path, another one reg-to-reg path, and the other one reg-to-reg path. So there are 3 registers. So the combo path delay between the first reg-to and second reg path, it's huge. But the combo delay between reg-2 to reg-3, it's less. So at that time, what we can do now, we can use the borrowing concept of latch, and then we can borrow some time reg-2 to reg-3 path, so that our timing gets meted. So for those instances and all, we can use latch, sir. But normally we'll be preferring flip-flops.
Fine. Then what do you mean by slack?
Yes, slack is basically arrival time minus required time, or vice versa. If it's with respect to setup slack, then it's required time minus arrival time.
I'm
If
not going with setup or hold. I'm just asking you to define slack. Just define a slack.
Basically, I was defining with respect to this formula only. So if I define it in a general way, okay. So if I try defining it in a general way, slack is, I mean, if it's like we are expecting the data to arrive at this time, and if the data has arrived before that, then we can say that it's a positive slack. If the data has arrived after our expected time, then we can say that the data, I mean, the slack is negative. So this is how we can define the slacks regarding the data arrival.
No, just define a slack. What would you say? What would you say in a line that slack is?
Okay. Slack, yeah, I'm not getting that particular thing to say it in just a definition. I'm like, yeah, the main difference between the arrival time and required time, or required time and required time, is the slack.
What do you mean by skew then?
Skew is like, skew is, I mean, the additional delay, not only delay, but skew is like, so consider there are two registers, and with respect to positive register, I am adding one buffer. So the latency for the register 1, it will be more compared to the latency of the register 2, because here there is a buffer and it will be adding a delay. So for the clock oscillator to reach the clock pin. So that is how skew works. It will be adding the delay. Skew can be even defined with respect to
define. You are explaining. I'm asking you to define.
Okay, skew, I can define it like, I mean, the time difference. The time difference in between the two sequential cells for the data to arrive at the pin of them. So.
What do you mean by a propagation delay then?
Propagation delay, it's like when a signal transition is happening, then, sir, can I explain that with respect to graph?
Oh,
in this only I'll explain it.
Krishna.
Sir.
Yeah. Hold on, Mahesh. What do you mean by a clock?
Sir, shall I do this or not?
You continue doing it. Explain me later. Krishna, define clock.
Clock nothing but inversely proportional of the frequency, sir.
I'm asking you to define clock, not clock. What do you mean by frequency or time? I'm asking you, what do you mean by a clock? Simple.
So, can I explain this one thing?
Yeah, continue, Krishna. Hold on, Mahesh.
Okay, sir.
Clock nothing but a continuously signal, sir. Continuously positive and negative signals.
Then what if I am having a square wave? How can you tell there is a negative signal in that?
That's square with a 0 or 1.
Then where is the negative here?
Continuous pulses, sir. If clock nothing but continuous pulses. Oh.
Then in sine wave you won't have pulses. Fine. Mahesh, continue.
Yes, sir. So you can see the screen, right, sir?
Yeah, I can see.
Yes, sir. Consider this this transition. So the transition is happening from 0 to 1. So when the transition is happening from 0 to 1, or it considered as a rise slave, so at 50% duty cycle, with respect to input and output, we'll calculate. That is what propagation delay is all about.
Okay. Krishna, what do you mean by fan out?
I don't know, sir. I don't know.
Mahesh, what do you mean by clock?
Yes, sir. So clock is nothing else but with respect to frequency, we'll determine the speed of our design, sir. I mean, greater the clock.
No, I'm just asking you, define a clock. With respect to digital electronics, define a clock.
Okay. A clock. I mean, clock is. I mean, the clock is the amount of period in between the transitions of our signals will be occurring, sir. I mean, we'll define a particular period for a clock.
See, what do you mean by a clock? Clock means what? Just define. I'm asking you to define in a one line. That's very simple, very basic thing. Define a clock. I don't need explanation or anything with respect to the projects or anything, because you are going to use clock in your project with respect to PD. It
Yes.
changes with respect to the DFT engineer. It changes with respect to the verification engineer. It changes with respect to someone who is using the clock in the lab, someone who is using it somewhere else. So it changes in digital electronics.
Yes.
I'm just asking you to define a clock with respect to everyone, with respect to digital electronics, which is applicable everywhere.
Okay. I mean, a clock is like a clock can be defined. It's like I mean, the time period in between which our transitions should be occurring. So I'm not getting the exact definition, sir. I'm sorry for that.
See, you have the signals, right?
Yes, sir.
Oscillating signal.
Yes, sir.
What do you call them?
I mean,
What do you call an oscillating signal? Continuously oscillating signal, what do you call them?
clock only, no?
That's it.
Yeah. Yes, sir.
Define fan out.
A fan out, it's like with respect to one single net or one single cell will be, I mean, one single cell will be driving more inputs, more outputs. I mean, more cells. Can I explain with that with respect to this diagrams?
Define it. I'm asking you to define.
Yeah, fan out
Define
is
a fan out. Number of inputs, outputs, whatever you are using.
Yes,
Define it like that.
basically there is one. I mean, the ability. I mean, fan out is nothing else but the ability of a cell which can drive several inputs. So that is what fan out is all about. I mean, one particular cell, it will be driving like some 3 to 4 inverters. So those 3 to 4 inverters can be called as a fan out number.
So fan out number for which you will sell, we'll say inverter sides or fan out side. Like if a particular cell is there, I'm having 4 inverters.
Okay.
All of them connected to a flip flop or something, some combinational circuit input.
Okay.
So the fan out of inverter, you will be saying the capacity of the inverters as fan out, or capacity of the combinational circuit input as a fan out.
No, sir. About regarding the inverters, regarding the inverter, will determine the fan out count.
So how I'm saying, see, I have a flip flop at once.
Okay.
At one side, or some combinational circuit, ADC. I'll consider it as an ADC.
Okay. So that will be driving those inverters, no, sir?
They will be driving whom?
The inverters.
How many? If I have a ADC of 7 inputs and 3 outputs.
Okay.
So now fan out, how much is my fan out?
With respect to outputs, it will be 3, no, sir?
Output. Okay. If with respect to input, will it be driving 7 inputs?
No, sir. Fan out, it's like one cell will be driving. One cell will be driving several inputs, sir, in fan out. If there are several.
That's what I'm saying. In a combinational circuit,
okay,
there is one cell. As per your what cell come, there is in a combinational circuit there is one cell. If it is driving 5 inputs, what's the fan out of it?
5, sir.
Right. Okay. What do you mean by fan in then?
Fan in the sense there are. I mean, with respect to this example only, sir. Take with respect to those. I mean, here one cell will be driving those 5 inverters, no, sir. take the example of those 5 inverters, and those 5 inverters will be connected to one common cell. So that 5 inverters can be said as the fan-in of that particular design.
Fine. Define. Hold on, Krishna. Define mux. What do you mean by mux?
Mux nothing but I explained 2:1 mux.
Just define mux. That's enough.
Sir, number of inputs apply and output given to one single output.
Okay.
Matlab, 2 inputs and one special cell, then output is 1, sir. So number of
Come again. You said something. Repeat again.
If we apply to 2 inputs. 2:1, 4:1, and 8:1. Sir, mux nothing but 2:1 and 4:1, 8:1. Well, number of inputs are given, and then output will be single output.
How can you say that number of inputs will give single output? What are the conditions for number of inputs to be single output? I just need a definition of mux and an explanation of mux. That's enough.
Explanation?
No, just define mux first, and then you can explain.
Number of inputs is given, and single output will be, that is mux.
Explain it. How will 4:1 mux work?
4:1, sir. And just inputs is 2:2.
No, don't write. Just explain by words.
Sir, ABCD inputs, sir. 2 are S0, S0, and one output is this.
So how does that work?
I don't.
Okay. Define mux, Mahesh.
Yes, mux is basically a combinational circuit. It's like many to single output. However, many inputs can be given to single output. It's like it's with respect to, I mean, it's with help of select lines. So basically, if there are 2 inputs, then there should be one select line with respect to the formula. So with respect to the select line will determine what input should be given to that particular output. So.
Okay, even a 4:1 mux, I want to send the third input to output. What would be the combination of your sequence selection lines?
It should be 1 0, sir.
1 0.
Yeah.
Okay, I'll give another thing. I want I0 to be fed in the I3rd, means third combination of the selected. What can you do?
I0 to be fed to I3.
I3. I0 to be fed at I3. Yeah, I0 to be fed at I3.
I mean the value at I0 to be fed at I3 or what?
I0 data needs to be
okay
at the output when the
okay then at no sir at see if it's like I0 data, if I have to send it at I3, then at I3 instead of giving 1 1 I'll give 0 0. So
no the see, understand my question.
okay.
I'm having a I0 data.
Okay,
there's a data. I will consider it as B. Okay, the data B needs to be at the output when the combination is 1 1. Okay, you are feeding A, B, C, D, E. Okay, as an input. Okay, you can replace the input also.
okay.
B, C, D, E. Sorry, B, C, D, E. Yeah, correct. two inputs S0 and S1. For the combination of 1 1, I need the B to be at the output. You have two ways to do the same thing to get the output. How will you do?
I mean, like, if the data is at I2, I have to send it at I3 or I4, like that.
Okay, it's at I0. Okay.
Okay.
The B is at I0.
Okay, the data is at I0.
I want that to be when the combination is 1 1.
Okay, when the combination is I1 1, that I0, I mean, yeah, when the combination is 1 1, the I0 data should be fed instead of I3. Okay, with respect to gates, I don't think we can do that.
Krishna, question applies for you also. If you have the answer, you can answer.
Sir, I can even connect the inputs, no, sir?
How?
Directly or by using buffer?
Yeah, but how? To which input will you connect your inputs?
No, sir, if it's like when it's 1 1, if I0 should be displayed at the output, then I should connect I3, no, sir, if it's with respect to 4:1 max. Then
so what you will do then?
I can connect that with respect to buffer also.
You can connect. Okay, that's one method. What's the other?
With respect to select lines, I don't think we can make any changes, sir, because for 4 inputs, there should
be. See, you are feeding B at the I0. You want that at I3. You just can replace the B data at the I3. So whenever you are selecting 1 1, you are getting the output.
Yes,
this is the easiest way. Okay. If this is not possible, you can't modify your inputs. Then you have to add a bubble.
One thing, sir.
Listen to me. You have to add a bubble to your select lines. So when 1 1 is going to happen, it will get your that's it. Okay.
No, sir. I thought like I just thought like we are not giving any input. Only with respect to select lines, I was thinking, sir. If there is
you right, B, C, D, E, you're giving input. You can change the inputs. I said it at the first only.
No, sir. That I can.
You have to be very careful when the interviewer is asking you a question.
Yes.
You have to grasp all the data. Okay.
I'm sorry for that.
Fine. Krishna, are you comfortable somewhere in the analog questions? You have any idea about the analog design questions or analog electronics questions?
No, sir. Okay. DFT, sir.
No, I don't have much idea about the DFT. We'll continue with the digital only. Okay. What do you mean by Johnson counter? How does it work, or any idea about it?
Forgot.
So Johnson counter looks like it will work like when the complement of output of the last flip-flop is connected to the input of the first flip-flop. That is how Johnson counter works, sir. So in Johnson counter, it's like number of states is not equal to number of flip-flops because it's twice compared to number of states. In Johnson and ring, that is the main difference.
So can you have a synchronous Johnson counter, asynchronous Johnson counter, or any one of them? Like
synchronous Johnson counter, sir.
Asynchronous, can you have it?
Asynchronous, I don't think, sir, you can have.
Why?
Because in synchronous, it's like all the clocks will be connected to the same source, no sir. But in asynchronous, it's like the output of one flip-flop is connected to the clock of the next flip-flop. So that's the main reason.
We can do it, right?
Yeah, we can.
Your output will be connected to the clock of the next flip-flop along with the input for the next flip-flop. So what happens at that time?
No, sir, designing, I think it can be done, but operation, I think it will be slower, so compared to the synchronous Johnson counter.
Okay. You have learned PD, right?
Yes, sir.
Okay. What do you mean by antenna effect?
So antenna effect basically, cause of antenna effect, no, sir?
Just define an antenna effect.
Antenna effect will be caused whenever there will be an itching of the metal. So at that time there is a plasma which is, the itching of the metal will be done with respect to the iodized gas or else the plasma. So that will be depositing some charges, sir, onto the metal. So longer the metal, more will be the charges. So if the metal area will be long, then it will be it will be affecting the gate, sir. So it will be destroying the gate. So basically, how long the metal should be, that will be determined by the antenna ratio. So the area of the metal connected to the gate to the area of the gate. So for antenna ratio, we have two methods to reduce the antenna ratio. One is by using metal jumper and other is by using metal diode. So metal diode is not preferably used because metal jumper is widely used. Metal diode is only used whenever we are having the antenna effect in the topmost metal layer, sir. Because in metal jumper we'll be, in the metal jumper, if we are facing the antenna issue with respect to metal 2, then we are using metal 3 to get rid of the antenna issue with respect to the metal jumper. But if it's like the metal 3 is only the top layer, we are not having any other layer, so we can't use the metal jumper over there. So for those cases, we'll be using the diode.
So if you said that during the plasma etching, the gate will be exposed, so ions will be there, etc. and all. So if you are, while preparing, the step happens after certain duration. So if you are doing a plasma etching, you give sufficient time, right? After that,
yes,
you do the next etching. So
yes,
by that time, ions might get stabilized, or ions they need to be settled, right?
Yes,
why don't they get settled?
No, sir. See, sir, when I am using the technique of metal jumper, that is what what theory comes here, sir. Because yes, sir, I am having an antenna issue. Consider, for example, as metal 2. So I am using the help of metal 3 to fix the antenna issue of metal 2. So even that can be a thing like, when I connect to metal 3, even the charges will get. Even the charges will be coming again and again. I'll be facing that issue. But for the manufacturing time between metal 2 and metal 3, it will not happen in a short amount of time. The manufacturing time will be more, sir. So at that time, the charges would have leaked away. So we won't be having the effect of metal on the metal.
Krishna,
sir. 1 minute.
I'm having a lot of disturbance from you.
Yes, sir.
You can mute, okay, whenever you want to have a conversation.
No, sir. Just change this place.
Fine. Okay. Yeah, continue, Mahesh.
Yes, sir. That is what I was telling, sir. When we are using higher metal layers, that may be a question like, even when they are connected to metal 2, then again the charges which are at metal 3 might be coming to the metal 2, and again it may destroy the gate. But the manufacturing time between metal 2 and metal 3, it won't be within a short time, sir. It will be taking more time than expected. So at that duration, the charges would have leaked away. So metal 3 won't be affecting us after its manufacturing when it is connected to metal 2, because antenna effect is antenna will be seen during the fabrication. So this is the theory.
So if the antenna effect is seen during the fabrication process, then how does the tool determines that there is an antenna effect going to happen?
The tool determines the antenna effect with respect to the antenna ratios. If the area of the metal connected to the gate is more than what the area of the gate is, the antenna ratio will be getting from the flap. So with respect to that, the tool determines that there might be an antenna violation which might be occurring here. So it's the time you should get rid of that. So on that basis, we'll be doing that.
Okay, fine. So your antenna, in your antenna effect, how does your diode method work? Like if you are inserting a diode, how
Yes, sir.
does that work? How would it diffuse the ions present?
Okay. So basically, when we'll be placing the diode, we'll be placing it near to the gate. So what happens? How, with respect to diodes, the charges will leak away, in the sense, the diode will be a diode, but during the manufacturing process, the diode will be acting as a resistor, sir. So the current will always choose the low path resistive, the low resistive path. So with respect to that, when during the manufacturing process, as it's a reverse bias diode, so even it won't be altering during the functionality, because if it's a forward bias diode, then it may alter the functionality also. So we are using the reverse bias diode. So during the manufacturing process, it will act as a resistive path, so that the charges can leak away through that, so through that the diode.
I mean that, see, you said that, okay, what is the other end of the diode connected to? One end will be connected to metal, right?
Okay.
What's the other end connected to?
So other end, so whenever we'll be inserting the diode, if I have the violation with respect to metal 3, metal 4, I'll always prefer to insert the diode to the lowermost metal, sir, because see, even I'm having the violation at metal 3.
Yeah, I know that one end of the diode will be to the metal. I'm asking you about the other end of the metal.
Other end of the diode, other end of the metal, I think it will be through this. Yes, sir. Other end of the diode, I think it will be connected to the standard cell rail, sir. If it's with respect to the lowermost metal.
So what are your metal layers? Like you had, how many metal layers did you have?
I had 7 metal layers, sir. 4 of them.
What did the first metal layer contain?
The first metal layers were basically for standard cells, sir. Metal 1 and metal 2. And metal 3 and metal 4, basically we use that for clock routing. And metal 5 and metal 6, basically we use for power routing. Metal 7 was the topmost, top level metal layer. So we were not supposed to touch that, because it's coming
Krishna,
from.
you mute yourself. It's disturbing a lot. I'll ask you to unmute whenever needed. Okay? Yeah, continue.
Yes, sir. Metal 5 and metal 6 we are using for power routing, and metal 7 it was it was from top level, so we are not supposed to touch that, sir.
Okay. So in metal 1 and metal 2, you said that it's for standard cells.
Okay.
So what was metal 2 specifically, or metal 1 specifically?
Meaning, sir? What?
Like what did the metal 2 contain? It only contained standard cells?
No, sir. Even the signal routing can be done in any of the metal layers. So basically, as we go with respect to the flow, so firstly, we'll be doing the power routing, sir. Power routing is done with respect to the metal layers which have least resistance, so that more current can pass through that. So we'll be using power routing, and after power routing, we'll be doing clock tree synthesis. Clock tree synthesis, nothing else but routing of the clock before the signal routing. Why we are preferring clock routing before signal routing? This is the main reason, sir. Because if we do signal routing before clock routing, then the signal routing, they'll accommodate the metals which are free. And because clock is main here, because it is the main switching factor, so we should make sure that clock should get the higher metal, the higher metal layers with least resistance. So signal routing at the last step, it'll accommodate with respect to every metal layer, sir. Wherever it will find a place, the signal routing.
So why don't you prioritize your clock to be at the 5th and 6th metal layer, and power and to be on the 3rd and 4th? Why did you prioritize your power at the first?
Because supply voltage is important, no, sir. Because if we are not getting enough supply voltage, then we can face the issues of IR. Because basically we have to deal with IR also, because if we are not getting enough supply.
So for you, what's important? For you, power managing IR drops is important, or managing the clocks or clock things are important?
No, sir, both are important. But as we go with respect to the flow, firstly we'll be doing the power routing, no, sir. So we should make sure that.
Oh, you can do the CDS also.
We
Once you are
can,
placing the
yes,
critical
sir.
switch to the power
Yes,
routing once you are
consider that
placing.
from, yes, sir. Just we'll consider that at metal 5 and metal 6 we'll be doing clock routing, and at metal 3 and metal 4 we'll be doing power routing. So what problem we can face is that, yeah, clock routing will be fine, but when it's with respect to power routing, then we'll be having the IR drop below the ratio, below the value which we are suspecting, sir. So we may face a situation like the transistors will not be switching as we expect, because there is no proper, I mean, we are supplying certain voltage, but when it is getting to the pin of the transistor, it's not the supply voltage which we are supplying, because every metal
Fine,
has
fine,
its
fine.
own
Got it.
resistance. Yes, sir.
Okay. Why do you place multiple vias in your project?
Yes, sir. Multiple vias. One thing is like vias are basically added for the interconnect of the metals, sir. When it's with respect to one horizontal and one vertical metals, so we make sure that all of them are connected, so that the power supply will be continuous or throughout the design. And the other
Okay.
thing is like it's like yeah, we'll be adding extra redundant vias, sir. One reason for that is like, see, whenever there is a etching process in the metal, sometimes what happens in a the etching of the metal, it's like it's not proper. I mean, we have added one via, but it's not, I mean, it's not proper via. So we will be adding some additional vias, so that if one via is not proper, then it can go for some other vias as a backup, sir.
I was expecting different answer.
Okay.
This is all it, or you have any other answer for this question?
Yeah, via one basic answer is like for the continuous supply of voltages, sir. And other one, we are adding this more vias. Yeah, this one. And
Okay,
any
you
other.
have two metal layers like this, one X and Y.
Okay.
If you have multiple metal vias on this, what would that do from top metal to lower metal?
Oh, so you're asking regarding resistance, sir. Resistance effect with respect to via.
Hmm. Yeah.
Yes, sir. Basically, if it's parallel, then we won't be having the resistance effect. But if the vias are connected in series, then we'll be having
Okay,
the.
no. You are not getting that via factor. See, vias won't be in series. Okay,
Yes, sir. It should be in
vias will
parallel.
always be parallel. So if you place vias parallelly, what happens to your metal layers? See, between the metal layers, it will be parallelly. So it will reduce the resistance. That's what
Yes.
I was expecting.
Yes, sir.
If you
It
place
will.
multiple vias, it will reduce the
Yes.
resistance.
Yes.
It
Yes.
will offer the least resistance. That's why you
Yes.
are playing multiple vias,
Yes,
right?
yes, yes, sir. With respect to resistance, it will reduce the resistance so that more current can flow through it.
What happens if you reduce the resistance and more current flows?
I mean, sir,
What happens to your project when you reduce the resistance and more current flows?
it will be good for
What
our
factor
design.
can you
It will be
what
good for
factor
our
can you
design.
control with that?
We can control even this one. I mean, this issues of IR drop and all we can control, sir.
That's it. See, if you this was a straight question. There will be another question in a practical way for you. Like if
Okay.
I am having two metal layers, I'm having 18 6 VRs, but this is not sufficient. What will you do? And there is a IR drop or such thing. This will be
Okay.
the question. You have to tackle it in another way. Okay.
Yes, sir. So I'll be adding more VS in order to reduce the
So
resistance.
reduce the resistance, and that will in turn help me in the IR drop issues.
Yes, sir.
Okay.
Yes, sir.
Okay. Krishna, explain me the process of DFT. What do you mean by a DFT? What is the process that are involving DFT?
Sir, DFT is a technique. Is adding a testable feature to the design IC design. Sir. They're developing and applying the manufacturing tester. And manifest text to the defect, separate the defect one to the from a healthy one, sir.
Hmm. So, how does that happen?
Sorry, sir.
You are saying that to identify the defect, how does that going to happen in DFT? What's the simple procedure that's going to be followed in DFT?
And observability and controllability, sir.
How?
The DFT is nothing but some apply the some logic, sir, in DFT.
What do you mean by a scan chain in DFT?
Scan chain nothing but a normal flip-flop converted into scan flip-flop, adding the mask in the
where will be they located? What's their use? How would they work?
Scan chains, sir.
Yes, scan chain, scan flip-flops. How does your scan flip-flop works?
Scan flip-flops works in the is adding the some scan enable input, sir. Scan input. They adding the mask in normal converted to scan flip-flop, adding the mask, sir, in regarding the scan enable and scan input, and output will measure the scan out, sir. Is separate required to
identify a particular if you have a 5 scan flip-flops connected to the your testing area, like for 5 cells, how can you identify that there is a fault in one of the cell using your scan flip-flops?
Some applying the inputs, collect the outputs. That output is the
what inputs will you be applying?
Sorry, sir.
What input will you be applying?
Load, unload, and capture, sir.
Yeah, you'll be supplying something right to your scan flip-flops. What is that called as? Something you'll send something to your scan flip-flops to get. You'll be sending and you'll be observing at the output.
Sitting in serial manner, sir. Number of scan checks are sitting in serial manner, sir.
Yeah, what's the input for all of them? You call something for that. There's a name for something input which you are going to provide.
Data, sir. Data input.
Any idea, Mahesh?
Yes, sir. I know few steps regarding scan chain and DFT. Basically, design for testability will do in the sense we will not see the overall functionality. We'll just see, for example, an AND gate is working like an AND gate or not. So it's like a scan chain and scan flip-flops are used wherein with respect to this one, sir, ATPG, automatic test pattern generator, we'll be getting some patterns. So that will be fed in a serial way with respect to the concept of shift registers. So we'll make sure that the input given here will be catching at the outputs, and with respect to that, if we are getting the expected output, then we can make sure that this thing is working in this way, so this is fine. If it's not working in that way, then we can figure that out what is the problem, and again we should go for the DFT again.
What's that input called as?
Scan input, sir. The patterns.
Pattern. Okay. Fine. Okay. What's the nanometer you worked on, Mahesh? Your project was
14 nanometers.
How much was the standard cells present?
Standard cells were close to 30K, sir. Basically, we started with 38K, but after clock tree synthesis and all, the tally was close to 40K.
Who was the instructor for you?
Srinath.
And anyone else?
STA was handled by Shilpa ma'am. The PD was handled by Srinath. Basic logic design and all.
So, what do you mean by multi-cycle path?
Yes, sir. Multi-cycle path, I'll explain that with respect to an example. Consider that there is a edge-to-edge path, and the thing is like the period the period for that is like 2 nanoseconds.
Krishna, can you continue?
Okay, consider that there is a edge-to-edge path, and it's like the period for in order to get the positive slack, it's 2 nanosecond. But the combinational delay itself, it's 3 nanosecond. So however we try or whatever, techniques we try to get the slack under control, it's not possible, sir, because the combo delay is itself greater than the total time period. So at that time, what we'll do now, we'll declare a multi-cycle path for setup as 2 and for hold as 1. So it's like we'll be skipping the next edge and we'll be capturing it at the second edge, sir, so that our period will be 4. So we'll be capturing the data.
Okay. What do you mean by false path then?
False path in the sense, yes, sir. It's with respect to this. I'll explain with respect to this reg to reg path only, and I'll be having one this one mux which is connected to enable. So it's like if the enable is 0, then it's like the path should be from from this reg to reg path only. It should go from, if the enable is 0, then the data which is present at I0 it should go. No, sir, it should not go from I1. So if it is the STA will not be knowing the functionality, so it will be calculating the timing between all those stuffs. So for those cases and all, we'll be defining the multi-cycle paths.
The false path I'm asking you.
Sorry, yeah, false path, sir. False path.
So, for example, if you have a combination of, if you have a register which is providing an output, okay, if you are going somewhere else and connecting to some of the combinational input, what do you call that path as?
I mean, reg to reg path is connected
to a register output going and connecting. The output is going to be connected to some of the combinational input.
Okay.
That's the end. Okay, that's the end path.
Then it's reg to out path, no, sir. Yeah.
So what do you call? What's that path called?
Reg to out path.
Do you have a reg to out path?
Where, sir? In our design?
In a legal paths, like in the
we'll be having reg to out into.
What are the 4 paths you are going to define?
Yes, reg to reg, into reg, reg to out, and into out. Yeah,
reg to out.
Yeah, these are the 4 paths, timing paths.
Fine. Okay, fine. We'll end this, I guess. Everything was good. Mahesh, you are doing good. You have to improve some part in your basics. That will help you a lot, because most of the interviewer will always choose you to answer the basics, because they will check you for the basics than anything else. Yes. There are some companies, some interviews, those who will check you even with the semiconductor area. They'll say, what do you mean by a semiconductor? Define semiconductor. You have to answer. They'll come with they will even dig even deeper to the level where you will have to answer from the valence electron level and conductivity band. From that level, they will start to dig. You have to be there. And I haven't asked anything about analog electronics. There will be questions on analog electronics also, because you're on VLSI and you have to know the CMOS theory and analog electronics. Yes, you have to have the BJT knowledge, MOSFET knowledge, everything, all of that. Not to depth, but to an extent where you have to have that knowledge to understand all of this. Okay. But from that, digital is good. You have to go to some basics and all.
Yes, sir. Regarding
PD is all okay, but in PD you have to work on some techniques or some questions or some areas where the answers are targeted to solve an issue.
Yes, sir.
Okay, yes. The things will be targeted to solve an issue. For example, the VIs. The main purpose of VI is to reduce the resistance.
Yes, sir.
Provide the connectivity and reduce the resistance. So you have to be specific with the answer. And always, whenever they are asking you, try to brief it. Don't elaborate it. Don't stretch a lot. Okay, try to elaborate it. And that will add a point. If you start elaborating one or the other way, anywhere in the middle, you will get stuck and you will get caught to that interviewer, and that person will pick the topic and drag you till the end.
Yes.
And you don't want that topic to be discussed because you are weak, and that person will drag it. If you don't know, you can say no also. Okay, no worries. But it should not be the same answer for all the questions. You did well. Keep it that, and some some things you have to recall, some basics and all.
Yes, sir.
Apart
Regarding
from that,
this,
everything is there.
I mean,
And you try applying for this Thinsil technology. They are hiring PD right now.
okay.
Thinsil technology, you can find it. That will help you. Okay, they are paying an initial stipend of 25K at the start, and as you do well, they'll pay you more. And it's a service-based company. Okay,
Okay.
they are hiring. You do that thing. And coming to Krishna, Krishna, you have to work a lot. Everything. I'm not going to point out anything particularly. Everything from digital basics to your DFT areas, every terminologies you have to improve a lot, and you have to know what you have done in the previous year. Also, your BTech project, your regular working area, and your MTech project. Because some interviewer will ask something about those things because they are interested in those things. If someone is interested in the area which you have worked, the person will surely take your projects and ask you a lot of questions on them. And yeah, be confident. Try to make sure that you attend the interview in a regular manner. For both of you, make sure that you attend from at least you have this much of your view to the interviewer. Don't be too close to the like this, or don't lean completely backward. At least your shoulder length should be visible to your the interviewer, and your hands kept calm when you are attending through online mode. If it's through offline mode, you know the rules. This is what the first thing, and make sure that you are sitting in a sufficient light area and all. Always try to use the online mode. It means if you are attending to online, try to use the whiteboard on the meet and try to explain them than explaining on the paper, because that's totally invisible for us to understand. Okay, and yeah, work a lot on everything. Start from today. It's not going to take much time. There are many websites, many tutorials, some NISO Academy, even VLSI for all is also providing some notes and all. Start with the basics of digital. At least you can sustain there, and after that in DFT you can manage if you have learned everything completely. So go through the basics of digital, because they'll touch a lot in the basics of digital, and then come to your areas. Okay. Any questions from both of you?
Sir, I was having questions regarding this one, also the openings regarding the backend.
Sorry, Krishna, mute.
I mean, the openings in the backend area, sir, there are not
Very difficult. Very difficult. It's very difficult right now. You are not able to fetch any openings, and it will take another maybe 2 months or 1.5 to 2 months would be the maximum, I would say. By the end of March, or at the midweek of March, yeah, there are openings, but very limited and service-based companies, and don't expect much salary from RV. They are not going to place you in good companies. They are just projecting those people who are already placed offline. From off campus, there are many people who have been placed in Mediatek and all. They are picking those names and posting on their website, posting that they have made them to get placed. But that's not the thing from RV. You have to try outside only. Don't rely on RV. You will not be placed. Yeah, you try to go to any companies. Initially, you can work for some little stipend, and then later stage, they'll put you to the client if it is a service-based company. In product, they'll hire you directly. They don't do all of this thing. And in product, you will learn a lot. Okay, so be specific. Yeah, just be brief with your answers. I would say you have to cultivate that habit of being brief than explaining a lot. So that will temper a lot. So be brief. It will work. Okay.
Omni Design Drive, I've made this mistake.
I heard your story. I heard your story from Omni Design. I heard your story that you gave, and there was a lot of answer sheets given, and you took all of them and explained so long that the Omni Design people wanted that to be in brief. I understood. I heard your story. I know your story also.
Yeah.
Okay. Any questions, Krishna, Mahesh?
Yes, sir. This regarding this open, I am daily seeing the Naukri or LinkedIn and all. I mean, there are openings, but there are no openings for freshers, sir. So how to
actually getting openings in PD is very difficult, very difficult, and that too for fresher is very difficult. So keep trying. You might get, but not initially, but you have to wait for this time. And you are 48, and B49 will be coming in another 4 months output. And these RV people will neglect your B48 and they will focus on B49. In between that only you have to get placed. Yeah, that's it. You can't do anything. You have to approach your VLSI friends who are working in institutes and keep checking all of those company websites, synopsis, guidance everywhere, and try to ask for any one of the employee working there to refer you, and you can give the interviews. Be prepared. That's what you can do. You follow these some Instagram those pages which post jobs on about VLSI. They will also help you. That's it. Apart from scrolling LinkedIn and checking on websites and reaching out to your networks, there are no other ways to get into this company. And getting a job in PD is very difficult. Try, let's see, if you are getting synthesis also, you can go because it comes under PD. The STA is also fine. Yeah, something, any of these three, PNR, design, everything, any of these three can work for you. Okay, go with it.
Okay.
Yeah.
What all areas should I focus more, sir, regarding the preparation?
I said right, the basics.
Okay.
Start with the semiconductors area, like the basic how trivalent, pentavalent impurities, semiconductor, adding all of them. Focus there. Then come to some areas like these gates, some of these basic definitions, and then go with the transistor levels, CMOS, and they'll give you some questions on CMOS also. What happens if I remove the PMOS in a inverter? What happens if I remove the NMOS in an inverter? Those kind of tricky questions. You can get it on YouTube and some websites on Google. Focus on them and focus on analog also. And if they are going to take you for analog layout, then you have to focus on network also. If you are only sticking to PD, then analog CMOS theory and digital is more than enough. And be specific with the waveforms. Focus on waveforms also. The drawing the waveforms, etc. and all. D flip-flop, the flip-flop waveforms, everything. That will help you, okay?
Okay.
And install is fine.
Okay.
So what about the DFT, sir?
Sorry?
Market DFT.
DFT has huge openings right now. You can find a lot of openings when compared to the PD.
Sir, everyone asks a 3
Actually, you have to reach to your contacts, Krishna. There are openings. It's not like there are no openings. There are openings for DFT actually. I have been seeing DFT openings for freshers from past 1 month. From January mid to February mid, I have seen every single job having zero experience for DFT. Maybe you are not going through the things clearly. Yeah, that only the same thing. Go through the websites of the company, check there. You can apply there. Try reaching to your networks. Yeah, those things you have to do, and it's not like 1 day or 2 days. You have to do it regularly, and you have to check multiple times, morning, evening. Some post the updates after 4-5 p.m. So yeah, that's what you have to do. Okay. Keep checking. You will get it. Okay. No other questions, right?
Yes.
Fine. We'll end the meeting. Okay.
Okay. Thank you.